sketching reciprocal functions. So a reciprocal function is going to be something like this, where we have some function f of x, or y equals f of x, and then we want to sketch what y equals 1 over f of x would look like. And the best way to do this is just with an example. So let's draw our xy axis in. And first we're going to draw f of x equals x squared. We'll draw this in blue. And that's just going to be our normal parabola. Now, let's draw g of x being the reciprocal, which is just 1 over f of x, which is just 1 over x squared. Now, how do we go about and draw its reciprocal given a function already? Well, we look at some key values and we think about what's going on. So, and the key values we're talking about are the y value. So the y value here is 0, and 1 over 0 actually creates a vertical asymptote. So what we're going to have on our reciprocal function is a vertical asymptote here because we have a y value of 0. Now, let's think about the y value over here. We have a really small y value, and 1 over a really small y value gets a big y value. So we're expecting some part of the curve approaching infinity here, because as it gets smaller and smaller towards 0, this gets closer and closer to infinity. Then, as these values of y get larger and larger and larger, the reciprocal function gets smaller and smaller and smaller. So what happens is we get smaller and smaller and smaller. And the point where they cross is actually at x equals 1, because 1 over 1 will also equal 1. So we know that the point where they cross has to be where x is equal to 1. On the other side, we just have the exact same situation. All these y values are really small, and 1 over a small y value gives a really big value, and as they get smaller, they approach infinity. And the exact same thing happens on this side, and where they cross will actually be -1 in this case. Let's look at another one. Let's look at y equals x cubed plus x minus 2 squared minus 5. And sketching this curve out, we're going to get something like this. And we want to graph 1 over y. So it's reciprocal function. You can call this g of x, because that'll just end up being 1 over x cubed plus x minus 2 all squared minus 5. Now again, we sketch this looking at key values of y, and whenever y is equal to 0, we have a vertical asymptote. So let's go ahead and draw those in, because we get 1 divided by 0, which just can't happen. And now we need to look at what happens with each of these sections. So let's start over here. As these y values are all negative, and as they get closer and closer to 0, the 1 over those values approaches negative infinity. So we're going to get something like this. And as those values get bigger, they actually approach 0 for y. So there'll be an asymptote there. These tiny positive y values, 1 over those, give really large values. So we're approaching infinity. Same thing over here, tiny y values, 1 over those tiny values approach infinity. And this point here is just a positive y value. Don't know exactly what it is, but 1 over that positive value will just be another positive value. Depending on what the value is, that's where the curve would, 1 over that value would be here. Not sure if it should be there or here because we just don't know what that value is, but it will be something like that. These are all negative y values. Then we have really small negative y values. 1 divided by those approaches negative infinity. And the same thing happens over here. So all those approach negative infinity. And this value here is a negative y value, and 1 over that negative y value will be another negative y value. So again, we're not sure on what that value is, but whatever, it all depends on what that value is for y. Here we have small positive y values. 1 over those gives us really large y values approaching infinity. And as these values get larger, 1 over those large values gets smaller and smaller and approaching 0. So our graph ends up being that. So everything in red ends up being our reciprocal graph.